combination. But for this, we'll primarily be learning about permutation.
Permutation. A permutation of a set is, loosely speaking, an arrangement of its members into a sequence or linear order, or if the set is already ordered, a rearrangement of its elements. The word permutation also refers to the act or process of changing the linear order of an ordered set. Basically, it's the counting technique to find a certain order. There are 4 ways to solve for a permutation, including its rule in it. Linear permutation, which uses rule 1 and 2 of permutation. Permutation with repetition with rule 3. Permutation with identical objects and rule 4. Lastly, circular permutation with rule 5 and 6 of permutation. But first, we must be able to identify if a problem is in need of permutation and things we need to know on permutation.
The most important thing we need to remember in identifying a permutation is that the order matters. The order of the sequence matters, whether is it a lock with passcode or a ranking of people. A definite sequence or order. If the problem involves finding a definite sequence, then we have to use a permutation. If there is a specific order or sequence, then we have to use permutation. So basically, if there is an exact order like an exact seat, exact position, or exact number placement, then we have to use permutation. Now here are some things we need to know before answering permutation. If you guys are not familiar with a factorial is the product of all positive integers less than or equal to n, or basically, is multiplying all the numbers before it until 1. Example, 3 factorial equals 3 times 2 times 1 equals 6. 5 factorial equals 5 times 4 times 3 times 2 times 1 equals 120. We also need to know the variable used in the formula. N is the number of options. R is the number of spots or position. K is equal to the size of the set. These are the permutation of the set. K is like in sequence, for example, A1, A2, and AN. But here it's like N1, N2, and NK.
Now that we have identified a permutation, then let's start on how to solve a linear permutation and its rules. Linear permutation, an ordered arrangement of objects in a line. Rule number 1 can be applied to permutation, which is the number of permutation of n distinct objects taken all at once is denoted by npn and defined as npn equals n factorial. Let's say we're gonna arrange 3 picture frames in a row. So we're gonna take all the possible arrangement at once, which will be 3p3, which can be solved as 3p3 equals 3 factorial. 3 factorial equals 3 factorial, which is 3p3 equals 3 times 2 times 1, which the answer is equals to 6. Let's give another example. In how many ways can 10 cyclists in a cycling tournament can be ranked from 1st to 10th place after the tournament? npn equals n factorial, 10p10 equals 10 factorial, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1 equals 3,628,800 ways.
Rule number 2 is also applied to linear permutation, which is the number of permutation of n distinct objects taken R. At a time is defined as npr equals n factorial over n minus r factorial, where r is less than or equal to n. Let's have an example. Let's use the one from before. If only top 3 finalists from 10 cyclists in a bike race can move to an international cycling tournament, in how many different ways can the first, second, and third ranks be awarded? Let's analyze the problem. Out of the 10 cyclists, we will choose top 3 finalists. 10 are the options, which is N, and the spots and position are 3, which is R. So, N is equals 10 and R is equals 3. And NPR equals N factorial over N minus R factorial. Then, 10P3 equals 10 factorial over 10 minus 3 factorial. And 10P3 equals 10 times 9 times 8 times 7 factorial over 7 factorial. The reason why we stop at 7 factorial, because in dividing fraction we can just cancel it out. So, we can cancel both 7 factorial in the numerator and denominator. This is much simple because we don't have to find the factorial of both and divide them. 10p3 is equals to 10 times 9 times 8, and 10p3 is equals to 720 ways. So that is all for linear permutation.
Permutation or repetition. This method is used when we are asked to make different choices each time and with different objects, which uses the rule number 3. And rule number 3 is the number of permutation of n objects taken r at a time with replacement or repetition in n raised to r. Here's an example. In how many ways can you answer a 10-item true or false question? So we just raised 2 raised to 10, which will be 1024, and it's 2 because there's 2 options, which is true or false, and 10 for the items. Let's have another one. A security company offers an electronic security system that utilizes the number 0 to 9 for a 5-digit security code. How many possible security codes are available if repeated? So from 0 to 9, there are 10 numbers, and those 10 numbers are options, while the 5-digit code is our order. So the answer would be 10 raised to 5 equals 100,000 security code order, and that is all for permutation with repetition.
The third method, namely permutation with identical objects, is an ordering of those objects. When some of those objects are identical, the situation is transformed into a problem about permutations with repetition. Our rule is our rule number 4. This reads, the number of permutations of n objects where n1, n2, all the way to nk give the number of each identical type of object. It is defined as n factorial over n1 factorial, n2 factorial, all the way to nk factorial. Here's an example. How many permutations are there from the word Anna? As you can see, there are 4 letters. So we should distinguish the 2 A's and the 2 N's from each other. By looking at the 2 A's, there are 2 ways you can permute them. For instance, A1 and A2. And then also A2 and A1. Same thing with the 2 N's. Since the numbers are identical, these duplicates must be removed by dividing the 4 factorial possible different arrangements by the 2 factorial and the 2 factorial rearrangements for A's and N's respectively. So as per our solution or rule number 4, we have to find the n factorial, n1 factorial, and n2 factorial. We can determine which one of these are if we would analyze the given problem that was given to us. So as you can see here, n factorial is 4 factorial over n1 factorial or 2 factorial, and n2 factorial, which is 2 factorial as well. So we would factor the 4 at the top first. It would be 4 times 3 times 2, and that will be over 2 factorial and 2 factorial as well. As you can see, there is a 2 factorial at the top and a 2 factorial at the bottom, so we can just cancel one of them out. So it will be 4 times 3 over 2 factorial. So if we would factor 2 factorial, it would be 2 times 1. So if we were to multiply 4 times 3, it will be 12 over 2, because 2 times 1 is 2. So if we were to divide 12 divided by 2, the answer would be 6. Therefore, there are 6 different permutations of the letters in the word Anna. Let's have another example. In how many ways can the letter of the word statistics be arranged? So first, there are 10 letters in the word, so our n is 10. Because as you can see, for the identical ones, we have 3 S's, 3 T's, and 2 I's. So it will be 10 factorial over 3 factorial, 3 factorial, and 2 factorial. If you are wondering why we didn't include the A and the C, it's because they're only 1, and by multiplying something by 1 will just give the same. So first off, we must factor the 10, so it will be 10 times 9 times 8 times 7 times 6 times 5 times 4 and times 3 over 3 factorial, and 2 factorial. So as you can see again, there's a 3 at the top and the 3 at the bottom, so we can just cancel out the 3 factorial. So it will be 10 times 9 times 8 times 7 times 6 times 5 times 4. And then if we factor the 3 factorial that was left, it would be 3 times 2 times 1 and then 2 factorial. And so 3 factorial is equal to 6, so we can just cancel out the 6's. So it will be 10 times 9 times 8 times 7 times 5 and times 4 over 2 times 1. So we can just multiply it. It will be 100,800 over 2. And if we were to divide that, it would be 50,400 ways. So in other words, there are 50,400 ways we can permute the word statistics.
The next or fourth method is what we call circular permutation. Circular permutation is the total number of ways in which distinct objects can be arranged around a fixed circle. We use the fifth rule of permutation to solve it. Permutation rule number 5 reads the number of permutation of object around a circle is defined as n minus 1. Let's give an example. In how many ways can 5 people be arranged to sit down a circular table? So we will be using the solution of permutation rule number 5, n minus 1. So the first, what is n? If you analyze the question, n is 5 because there are 5 people needing to be arranged around a circular table. So it should be 5 minus 1. So 5 minus 1 is 4. So it should be 4. So multiply 4 times 3 times 2 times 1. So the answer should be 24. So the answer to the question is that there are 24 ways 5 people can be arranged to sit at a circular table. But wait, what if let's say the n object is inside the circular object itself? Let's say in this example, in how many ways can 5 different gemstones be arranged in a bracelet? As you can see, the 5 different gemstones are arranged inside the bracelet itself and not around it. That is where the other formula comes in. N minus 1 factorial over 2. N minus 1 factorial 2. So first you find your n, which is 5. 5 minus 1 factorial 2. Then subtract 5 minus 1. Then the answer is 4. 4 factorial 2. 4 times 3 times 2 times 1 divided by 2. If we multiply 4 times 3 times 2 times 1, the answer will be 24. Then we just divide that by 2. 24 divided by 2, hence there are 12 different ways to arrange the gemstone in a bracelet.
Linear permutation are also related in circular permutation. Linear permutations are circular arrangement relative to a fixed point. In other words, it means that the number of permutations of n objects arranged to a fixed reference point, or usually the circle, is equal to n factorial. Let's introduce our next rule. Permutation rule 6. The number of circular permutations of n objects taken r at a time is npr over r. Let's give an example. In how many ways can 8 delegates in an international conference taken 5 at a time be arranged around a circular table? First, let's analyze things. We need to first find our n and our r. By analyzing the example given, the n is 8. N is 8 because we're arranging 8 delegates around the circular object, while the r is 5 because it says taken 5 at a time. To answer this, it will be 8p5 over 5. Applying rule 2, it will be 8 factorial over 8 minus 5 factorial over 5, which would be 6720 over 5. Then we divide it to 5, and the answer is 1344 ways. That the 8 delegates in an international conference, taken 5 at a time, can be arranged around a circular table.
Now that we covered all the different methods and rules, let's answer some word problems. It would be ranked from easy, medium, and hard. Let's start with the easy ones. 3 couples have reserved seats in an auditorium to watch a musical play. In how many ways can they be seated if A. There is no seating reservation, B. Each couple should sit together? To answer A, since there's no seating reservation, we can take them all at once, which uses our rule number 1. Our n would equal 6 because in each couple there is 2 individuals, so 3 times 2 equals 6. So it would be 6p6 equals 6 factorial, and 6 factorial is equals 720. To answer B, we first take all at once the possible ways to arrange all the couples, and we also need to take all at once the possible ways to arrange each couple. So to arrange all the couples, it would be 3p3 equals 3 factorial equals 6. To arrange each couple, 2p2 equals 2 factorial equals 2. So overall, it would be 6 times 2 equals 12 ways to arrange each couple if they sit together. Second example would be the zip code used by the Philippine Postal Corporation to distribute mails and packages consists of 3 digits. How many zip codes are possible if there are no digit restriction? So analyze the question. We would be using rule number 3. Since we have to make different choices each time with different codes, and since there's no restriction.
So we can use 0 to 9. It would be 10 cubed, which is equals to 1000.
Third example for easy would be, in how many ways can the letters of the word mathematics can be arranged? So we would be using rule number 4 because it has identical objects and it has a problem involving repetition. Our n would be 11 since there's 11 letters in that word, and 1 would be equals to m, which has 2, and 2 is equals to a and is equals to 2, and 3 is equals to t and is equals to 2. To solve it, it would be 11 factorial over 2 factorial, 2 factorial, and 2 factorial. 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial over 2 factorial, 2 factorial, and 2 factorial. Cancel out the 2 factorial. So it would be 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 over 2 times 1 and 2 times 1. The answer would be 199,58400 over 4. And the final answer would be 4988600. Let's move on to some medium questions. First question. A password of 6 digits is made of digits 926002. A. How many possible passwords are there? B. How long would it take to try all the possible passwords if trying one password takes 5 seconds? For A, we'd be using rule number 4 because it involves repetition with identical objects. Our n is equals to 6. n1 is 6 and there's 2 6 in the digit. The same goes for 2, which is our n2. So our answer will be 6 factorial over 2 factorial and 2 factorial. Next is 6 times 5 times 4 times 3 times 2 factorial over 2 factorial and 2 factorial. Cancel out the 2 factorial and it will become 6 times 5 times 4 times 3 over 2 times 1. The answer will be 360 over 2. And the final answer will be 180. For B, we're just finding the time, so we just multiply the possible passwords, which is 180 to 5 seconds. 180 times 5 is equals to 900 seconds. Then we just divide it to 60 to convert it into minutes, which would be 900 over 60 is equals to 15 minutes. 8 students should be accommodated in 2 3-bed and 1 2-bedrooms. In how many ways can they be accommodated? First, let's analyze the question. So there's 2 3-bedrooms. So our N1 is equals to 3 and N2 is equals to 3. And there's 1 2-bedroom, so N3 is equals to 2. Adding all of those would give us 8, which is enough for the 8 students. So our N is equals to 8. We will be using rule number 4. 8 factorial over 3 factorial, 3 factorial, and 2 factorial. Next is 8 times 7 times 6 times 5 times 4 times 3 factorial over 3 factorial and 3 factorial and 2 factorial. Cancel the 3 factorial from the numerator and denominator. We can also cancel out the 6 since 3 factorial is equals to 6. So it will become 8 times 7 times 5 times 4 over 2 times 1. The answer will be 1120 over 2, and the final answer will be 560.
Let's have one more from medium. Alan's display begins with 3 letters. If the possible letters are A, B, C, D, and E, how many different permutations of these letters can be made if no longer is used more than once? N is equal to 5, which is our choices that was A to E, and R is equal to 3, which is our order or placement. So 5p3 equals 5 factorial over 5 minus 3 factorial is equal to 5 factorial over 2 factorial. 5 times 4 times 3 times 2 factorial over 2 factorial. Cancel out the 2 factorial. We will be left with 5 times 4 times 3, which is equal to 60. So we have 60 different permutation. Okay, so that's all for the video. We will give more examples. That is hard examples. But for the video, that's it. So far in the lessons, is there any problems? Any questions? You can type in the chat box or open your mic po. Seems like there's none, so we will move on to the hard questions for the presentation. So I will be presenting this presentation of the hard questions live. So because yes, it's difficult. So if you have any questions regarding the questions, you may freely ask. So starting off with the first hard questions, in how many ways can 4 married couples seat themselves around the circular table if A, spouses sit across each other, and B, men and women alternate? So let's analyze the question. For A, we would be using rule 5. So there's 4 spouses in 4 married couples. Considering one of the spouses has taken one of the seat, it would be n minus 1 factorial, which is also 4 minus 1 factorial. So 4 minus 1 factorial, it will be 3 factorial, and 3 factorial is equal to 6 ways. So that's our answer for A. And for B, men and women alternate. We would use the same rule, but we will multiply the factorial for the men and ladies to get the permutation. So considering one of the ladies has taken one of the seats, so it would be n minus 1 factorial times n factorial. The n minus 1 factorial is for the spouses, and the n factorial over here is for the men. So 4 minus 1 factorial times 4 factorial, it will be 3 factorial times 4 factorial. Then the answers for those is 6 times 24, and 6 times 24 is 144. So we have 144 ways to seat a man and a woman and alternate.
Okay, so I will be explaining the next example over here. So it reads here, a zip code contains 5 digits. How many different zip codes can be made if the digits 0 to 9 if no digit is used more than once and the first digit is not 0? This means, so analyzing our n would be 9. Is there a slide for this? Thank you. The n would be 9 and our r will be 4. This is because since 0 is not allowed, we know that 0 is not one of them. So the first digit is not allowed since it says here it's not 0. And since we can't use more than one digit, our answer would look like this. It means we're applying rule number 2. So it would be 9p4 equals 9 times 9 factorial is over 9 minus 4 factorial equals 9 times 9 factorial over 5 factorial. And so that's why it would look like this. If we factor 9, it would be 9 times 8 times 7 times 6 times 5 factorial over 5 factorial. So like stated in the video that we presented, we can just cancel out the 5 factorials. So it would be 9 times 9 times 8 times 7 times 6. The answer would be 27,216. If you're asking what the go back, if you're asking what the 9 in the front represents, it represents the first digit where 0 is not included, while the rest remains the same digit. So like that's the answer if you're wondering why there's another 9 there. Okay, next. Thank you. Okay, so for the next example, the third and last example, it says here, find the number of ways in which 5 people, A, B, C, D, and E, can be seated at a round table such that A and B always sit together. So, next, thank you. If we wish to seat A and B together in all arrangements, we can consider these two as one unit along with 3 others. That is why our n is 4 instead of like 5 since there are 5 people, because A and B are considered as one because they're always together. So yeah. So so effectively, we've to arrange 4 people in a circle. The number of ways being 4 minus 1 factorial is 4 minus 1 is 3, so it will be 3 factorial. And then if we factor 3, it would be 3 times 2 times 1. And the answer would be 6. So 6 times 2 is 12 ways. In the arrangements, A and B are always together, by the way. So they can also interchange seats in 2 ways. That is why we multiplied it by 2, because they can change. So 6 times 2 equals 12 ways. That's all. Thank you.
So far in the lesson, is there any questions? Because after this, we'll be doing the quiz. So start asking questions now, especially trying to identify if a word problem uses which method, which rule, and so on. So just type in the chat box or open your mic if there's any questions.
Okay, if I may interrupt, no, John Rain. Again, the quiz is accessible already, no? The time you started the discussion. So for everybody, earn 10 points. We will not force you actually to earn the 10 points because maybe it's so difficult for you, no, the lesson. But I think I am seeing there the words like leading, which one? Corporation and leaders. If I may ask the group to present the statistics and mathematics slides. Example. Okay, because I can recall that there are examples with those words mathematics and what is the other one? Statistics. Please show it to them again.
Yes po, wait lang po.
Okay.
I'm trying to find the slide.
So we do not force, no? If we cannot get 10 points here, it's okay. What I need you to learn from here is that really there is a guest speaker telling us about a new topic, a new lesson. And you cannot control them. Like for instance, for this one, it's really a recorded one. You cannot interrupt. No? Uh, Take yourself into a shoe we're in. It's really a guest speaker speaking, and it's shameful to be actually uh, uh, asking, no, while they are discussing. But when the Q&A or the forum is actually open for you, I doubt it if you could actually ask something because really, no, it's hard to understand. It's a time constraint, no discussion. Okay, talk about it, January.
Okay, so here in permutation with identical objects. So in this question, we will be using rule 4. Yes, rule 4, which is the number of permutations of n objects where n1, n2 to nk give the numbers of each identical types of object is defined as n factorial over n1, n2 to nk factorial. So the main point here is that there are some or our n, a part of our n, there is parts of it are repeating. So statistics, the n, there are 10 letters, and some of those letters are repeating. So identical objects, and those repeating letters, which is s. So s here, s here, s here. Then another one is t, which is our n2. So T, T, and T, which is also 3. And our another one that's repeating is I. So there's 2 I's, so our N3 is I. So our N1, N2, and 3, or basically N1 to NK or something, will be our denominator, and our N, which is the total number of objects, would be our numerator. So the 10 or our N would be factorial, and below will also be a factorial, but you will have to multiply it if necessary. So you factorial it 10 times 9 times 8 times 7 times 6, etc. Then there's a 3 factorial at the end, so you can cancel those out. Then 10 times 9 times 8 times 7 times 6 times 5 and times 4. And since 3 factorial is equal to 6, you can cancel out the 3 factorial and the 6. It would be 10 times 9 times 8 times 7 times 4 times 5 and times 4, and over to 2 times 1, and 2 times 1 is equal to 2. Then you multiply the numerator, it will be 100,800 over 2. Then if you divide it, it will be 50,400. So another example here is the math, if I can find it. Mathematics is here. Oh, this one. So another example here is the mathematics. Again, our n is our how many ways can the letters of the words mathematics can be arranged. So our n would be the word mathematics. So there's 11 letters in the word mathematics. But the problem here is some of the letters are repeating. So we collect those repeating numbers into n1, n2 to nk. So there's two m's repeating, so we put that as n1. There's 2 a's repeating, so we put that as n2. And there's also 2 t's repeating, so we put that as n3. If you're wondering why we don't include the other letters, because that would be n4 to 1 and n5 to 1 and so on. And multiplying something by 1 will just give the same answer, so we didn't include it. But the total numbers of our n1, n2, and 3 will be, if you add all our n1, n2, and 3 to whatever, it will be our n. So, but since we didn't include the ones because we're just gonna multiply, so we don't have to. So we just put the n1, n2, and n3 in the denominators. Again, n would be at the numerator factorial, 11 factorial, 2 factorial, 2 factorial. Then we do the 11 factorial. Then it will end at 2 factorial because there's 2 factorial, we can cancel it out. Then 11 times 10 times 9 times 8 times 7 times 6 5 times 4 times 3 over 2 times 1 and 2 times 1. That would be 2 and 2, and we just multiply it. It will be 4. So we multiply all the numerators. It will be 199,5A 400 over 4. Then we divide. It will be 4,989,600. Any questions?
Any questions so far? Spectators, audience?
Especially if we're gonna detect if a word problem, what do you call this? If a word problem uses what method, uses what rule. Is there any question regarding that?
Okay, if there's no more question, I think the observation na lang, no? We would want to hear from one of you. What can you say about the reporting, no, in general? Is it difficult, hard, or average, or... Sige, let's hear from anything, no, about the lesson, about the discussion, about the reporting.
Sir, there's a question po from Ozzy.
Sige.
So she said that how can we know what rule can we use for a problem? So it all depends. If you check all the definitions here, so let's give an example. For example, in linear, the word problem here. Okay, so here in rule number 1, it says the number of permutations of n distinct objects taken all at once is denoted by NPN. So the main words here in rule number 1 is taken all at once. So meaning there's no order, there's no position to be restricted for n. So we're just gonna take all the possible arrangement. So in the example here, arrange 3 pictures frame in a row. So there's no restrictions. We don't have to place it in first, second, or third or something. It just says in a row. So we're just gonna take it all at once. It would be NPN, n factorial, and 3p3 factorial, and so on. As for the rule 2 over here, if you analyze it, the number of n permutations of n distinct object taken r at a time is defined as NPR equals n factorial over n minus r factorial, where r is less than or equal to n. So Rn is so there's a specific positions or order that we have to put, which is our r, for our distinct objects, which is n. So in the example here, if only top 3 finalists from 10 cyclists in a bike race can move to international cycling tournament, in how many different ways can the first, second, third ranks be awarded? So you have to fill in a specific order or spots or position, which is our first, second, and third, for the top 3 finalists for our 10 cyclists, which is our n. So since we know that we have to fulfill a top 3 finalists for our 10 cyclists, and since it's also linear, so we have to use rule 2. So we are answering using it rule 2. Wait, it's loading. So there's the answer, and n is to 10 because out of the 10 cyclists, In RR, it's 3 because there's top 3 finalists, the spots that we need to fill in. Then NPR equals n factorial, n minus r factorial, and so on, which is 720 ways. Is there any specific rule that I have to show or specific method that I need to explain? Any questions?
Okay, if there's none, I'd like to interrupt since we are wrapping up. We are the sorry, the time now it's 12:28, right? If you notice, I do not know. If you notice, I denied you already accessing the Genio. Okay? So that's 5 items and 10 points. I'll give you more time, no? I think the whole day of to answer that quiz from this group. Okay? I think that you need to be actually needing your resources, like the resource from John Rain's group. Okay, John Rain, can you actually use the Google Drive and then give us some link so they could access your video? This one, no, the one that you presented a while ago, the video recorded or
I'll just
recording.
send the link in
Yes.
the GC po.
Okay, we do that, huh? Because they might not access it, no? They cannot access it. Why? Because it's too big, no? Memory is too big. That's why all of you try to opt to actually share your resources in the Google Drive. Do you know how to actually share that one in the Google Drive?
It's
May
already
tutorial
uploaded.
yan.
It's already
Okay,
uploaded
sige.
in YouTube, so they can just
Thank
click
you.
it and watch it in YouTube.
Okay, very good. Okay, so there's no way that I can force you to actually answer the quiz, no? In that 15 minutes, okay? Because really the topic of genre is hard, okay? The group of genres. Okay, and then it's okay, no? Okay, I'd like to remind everyone that this is not part of the quarter two, but if you want to actually earn additional points for your quarter two, then I think you should actually give time to this one. Remember, there are 10 points each. For the group reporting, there are 4 groups. That's 40. No, it's up to you if you want to earn those. Aside from the project that from this group reporting, and also the individual those codes, no compilation. Okay, that's the overview or the view that you must know from me when you will be asking what is content of the project all about in quarter two. Did you get it? Okay, sige. I'll give you the access for that Genio the whole day, no? And perhaps bit by bit, you go over those video, no? Okay, and then you can actually relate those items by, of course, no? Backing, forwarding the video. Okay, that's it, I think, for today, and I think your group did an excellent job, although it's very hard, really, no? Okay, and mind you, that topic cannot be actually taught in just one sitting, no? How many days? It's like Ceromel also, no? I just can't be actually moving on in the new lesson, cannot go to the new lesson without really uh, teaching you, no? The way you understand the lesson. It's really hard teaching mathematics, mind you. Okay, so congratulations, John Rain's team. And observe you are perfect in the attendance. You're all there, no? Okay, very good. It's just that you do not ask questions. Okay? Okay. So from this one, I want the others, especially that their reporting is hard. I do not know how hard it can be for you when you actually compare your reporting or your lesson to John Rain's lesson. And I hope that you learned. Let's see, no? If you've learned and you can. Okay, do not copy them. Okay, you do not copy them. Okay, you have your own way to present it. Okay, techniques, other approaches. It's up to you. Okay. Okay, sige. Let's go. Let's eat. 12:33 na rin.